Good afternoon, good evening, ladies and gentlemen. Welcome to another series of online lessons. If you haven't already, please subscribe to the channel, help the channel grow, leave a like, comment, and share. Now, in today's lesson, we're going to look at a very, very interesting theorem. And basically, we studied this theorem in our previous lesson. And in this lesson, we'll just prove or we'll derive, not proving, we're going to derive the theorem. All right, so the theorem comes from what is known as Euler's method or Euler's theorem, however you call it, Euler's formula. Okay, so Euler's formula basically says if you have e to the ix, okay, this is equal to cos x plus I sine x, and I've deliberately used x there, but you can use anything. It can be theta, it can be pi, it can be eta, whatever you choose to use. But if you have e to the ix, whatever x is there is the same x that is there. It is the same x that is there. Now, if we let x equal to theta from Euler's formula, we're going to have e to the I theta equal to cos, where there is x changes to theta, plus I sine, where there is x changes to theta. So I'm just basically writing the same thing with theta. Now for this part, we're going to multiply both sides of the equation by n. Okay, so if we multiply both sides of the equation by n, we know that maybe k raised to the power b, the power n, this can be written as k raised to the b times n, which can be written as k raised to the n times b, because multiplication is commutative. So we know that. So this side of the equation can be written as e to the I theta, then the n can be written in between there, n, like that. It's just the same thing, which is what we've done here. And this will be equal to cos theta plus I sine theta, then everything raised to the power n. So this will be our equation 1. Okay, so that is our equation 1. Okay, so now going back to Euler's formula, which is this that is right here. If we let x be equal to n theta, if we let x equal to n theta, what we're going to have is where there is x, we put n theta. What we're going to have is e to the I n theta will be equal to, where there is x here, there will be n theta. So that will be cos n theta plus I sine n theta. Just write it back here. Sine n theta, like that. So that is how it will be. So now this will be our equation 2. Okay, so that will be our equation 2. Now we see on equation 2 and equation 3. So let me just bring this here. So that, okay. So we see that on equation 2 and equation 1, e to the in, we have e to the in and e to the in here. So equating equation 2 and 1, so equating equation 2 and 1, on this part we have e to the in theta and e to the in theta here. So what we're going to have is what we call as the Moivre's theorem. So we'll start with this part. So that is cos n theta plus I sine n theta will be equal to this part, which is brackets cos theta plus I sine theta raised to the power n. Okay, let me just use the same color, raised to the power n. So basically, this is what we call as de Moivre's theorem, and that is how you derive it. Okay, so I'm just giving a brief of how to derive de Moivre's theorem. And let me just give one example from the previous lesson. All right, so just one example, maybe a bit intricate from the ones that we did in the previous lesson. So maybe you're asked to simplify this right here. So we have cos theta minus I sine theta to the power negative 2, then cos 3 theta plus I 3 theta to the negative 2, then cos theta minus I sine theta to the negative 4. Like that, you're asked to simplify this. So basically what you can do is you can maybe work out these that are the same here, but what you can also do is you can try to make everything to have the same value or the same value here. So we want to get rid of that positive there and that positive there so that it becomes, that negative so that it becomes positive, and the negative there so that it becomes positive. So what you should know is that cos is what we call an even function. So meaning that cos of negative theta is always equal to cos of positive theta. So cos is an even function. When you put in a negative number, it's the same thing as just that same number positive. So cos is an even function. So cos of negative theta is the same thing as cos of positive of that same theta. And negative sine of theta is equal to sine of negative theta, and vice versa. So sine of negative theta is negative sine of theta. So sine is what we call an odd function. If you put in a negative number, it will be negative of sine of that number there. So we can make use of this. So basically, negative I of sine theta can be written as sine of negative theta. And cos of positive theta is the same thing as negative of cos theta. So when restructuring this, we're going to have, let me use the blue pen that we have here. So we're going to have this cos theta is the same thing as cos of negative theta. Then we're going to have a plus I, then negative of sine theta is the same thing as sine negative theta, like that. Then everything raised to the power negative 2. Then here we have a positive already, so we don't want to change that. So that will be cos. For this one, we can just factor out the 3 using de Moivre's theorem. So that would be theta plus I sine theta. Sorry, this was supposed to be sine theta. I didn't even see that one. So sine theta. Then we factor out the 3. This will be 3 times negative 2. Then we can also do the same for the denominator. So cos, because of this positive that is here, we want to change this into a positive function. So cos of theta can be written as cos of negative theta, and we wouldn't change a thing because of this that here. Then negative of sine theta is the same thing as sine negative theta, so that would be plus I sine negative theta. Okay, so that is what we have. So now, and this is it raised to the negative 4. So that is, the denominator is raised to the power negative 4. Then now here we can factor out the negative using the Moivre's theorem again. So let me use magenta here. So that will be cos negative and negative will go out. So that will be theta plus I sine theta. Then we have negative 2 times the negative 1 factored out from here. Then times from here we have cos theta plus I sine theta raised to the power 3 times negative 2, that will be negative 6. Then on the denominator we're factoring out negative, so this is also negative here from the question, that is raised to the negative 4 there, as you can see. So factoring out negative here, we're going to have cos theta plus I sine theta, then to the negative 4 times the negative factored out from here, which is negative 1. Then now what we can do is we can start simplifying. So bases are the same, so that was our goal. We get the bases to be the same. Now if the bases are the same and we are multiplying, the powers will add. So basically what we're going to have is cos theta plus I sine theta raised to the power 2 times that will be 2. Then since the bases here are multiplying, so the powers will add, so that will be plus negative 6. Then divide by cos theta plus I sine theta raised to the positive 4. So this will simply be cos theta plus I sine theta, then 2 plus minus 6, so negative and positive, that will be negative. So this would be negative 4 raised to the power negative 4. Then everything down here. So since again these are dividing and they have the same bases, so the powers will subtract. So this will be minus whatever power we have here, which is 4. So basically this simplifies to cos theta plus I sine theta raised to the negative 8. Okay, so that is the simplification. All right, so if you have any question, please ask. But for now, this is about it. You can try out those problems in the exercise that you have, or is it an assignment that you have